Alright, now we're going to look at some magnetic forces, and in particular we're going to talk about a charged particle. This one's a little bit more complicated because now there's three factors in here. With left-hand rule 1, it was just current magnetic field. Left-hand rule 2, current magnetic field. But when you're talking about forces, you're now looking at three factors. You're looking at the direction of the field, you're looking at the direction of the velocity, and then you're looking at how the force affects this object. So when you're using your left-hand rule number 3, this one requires the most amount of thinking. Your fingers go from north to south always. Your thumb points in the direction of the current or in the direction of the velocity on the individual charged particle. And then you picture an imaginary arrow coming out of the palm talking about the direction of the magnetic force. Now this little example that I drew here for you and animated is going to show these particles heading in towards the page. It's a little tough to think three-dimensional, but these things are going to move into those magnets from north to south. I've got the light blue arrow showing the direction of the magnetic field. So you point for the electron. Since that's an electron, use your left hand. Your thumb is going to go into the page. Your fingers will go in the direction of the magnetic field. And you should see when the electron moves, in this case, the electron should get forced bent upwards towards the top of the page. So it's a little tough to picture this, but my thumb is going into the page. That's how this object is moving into the magnets, looking three-dimensionally. The magnetic field from north to south should show, and I'll back it up and let it run again, the electron having a force upwards. You can see in my palm, if I described it to you, is my thumb is going into my computer screen, my fingers are going from left to right, and my palm is facing up. And that's what I'm trying to show you in this case. If I did this with my right hand, then again, my fingers go from north to south, my thumb goes into the page, and since it's an opposite charge, we should see an opposite force. And the force on this charged particle should be downwards. Interesting to note, these are always perpendicular to each other. The velocity, the magnetic field, and the force are always perpendicular to each other. When that happens, that's when the force will be a maximum. If the velocity and the magnetic field are not perpendicular but some other angle, the force becomes less as a result. So ideally, you want to move perpendicular, but even if you move at an angle, you will still experience a force, but it won't be as large. And here's another thing that's quite interesting. Your force is in a different direction than the velocity. It's in a different direction than the magnetic field. That's a little bit weird to get used to. Usually you put a force and the object moves in the direction of the force. Well, the velocity is in a different direction first. The force is there to try to change its path. And that's why you can see these things being bent in a circular motion as they move through. So this is the magnetic force on a charged particle.